Let's discuss Unit 3 Programming Languages and Computer Graphics Solutions. Consider a triangle PQR with coordinates as P0, 0, Q2, 2 and R10, 4. If this triangle is to be magnified to 4 times its size while keeping R10, 4 fixed, then the coordinates of the magnified triangle are. Since they said R is going to be fixed, there will be no change in R coordinates. It is about magnification to 4 times, which means here we are talking about scaling transformation. Now let's take x and y axis here and we'll plot the points now. 0, 0 will be here. So this is point P. Then we have 2, 2, the point Q. Then we have 10, 4, the point R. So we'll form a triangle here. They are asking us to find the coordinates of P and Q, keeping R as fixed. We can control the location of a scaled object by choosing a position called the fixed point. In this case, it is R, that is to remain unchanged after the scaling transformation. Coordinates for the fixed point are taken to be xf and yf, that is x fixed and y fixed. As of this problem, we can take xf to be 10 and yf to be 4 because R has the coordinates 10, 4. This belongs to x-axis and this belongs to y-axis. For a coordinate position x, y, the scaled coordinates x dash, y dash are given by the following formula. So here the value of Sx will be 4 because it is magnified to 4 times. Similarly, this will be the value for Sy also. So x is also magnified to 4 times and y is also magnified to 4 times because they are given it is magnified to 4 times its size. It means the change will be applicable to x-axis as well as y-axis. Let's start with the coordinate P. So P has 0, 0 as its coordinate. So from this we can take x is equal to 0 and y is equal to 0. Now we have to find x dash. X dash is equal to x into Sx. The value is 4 plus xf. We have found xf to be 10 and yf to be 4 from our coordinate. So it is 10 into 1 minus Sx is 4. If we calculate 0 into 4 will give you 0 plus 10 into 1 minus 4 is minus 3. So 0 minus 30 which is equal to minus 30. This will be x dash. If you calculate y dash, so y into sy, again it is 0 into 4 plus the yf value is 4. 4 into 1 minus 4 which is equal to 0 plus 4 into minus 3. So this is equal to minus 12. So what is p dash from this? The new coordinates will be minus 30, minus 12. Then we will find for q which has the coordinates 2, 2. So from this we can take x is equal to 2 and y is equal to 2. Just substitute x dash is equal to 2 into 4 plus the same thing 10 into 1 minus 4 which is equal to 8 plus 10 into minus 3 will give minus 30. This will give a value of minus 22. Y dash is equal to same thing 2 into 4 plus 4 into 1 minus 4. So 8 plus minus 12 here and you will have minus 4 here. Now from this q dash the value will be minus 22 minus 4. So option number 2 you have minus 30 minus 12 and q you have minus 22 and minus 4 and r remains fixed. Option number 2 will be the right answer. If you take option 1 you have wrong coordinates here. So we can rule out. If we take third one you have wrong coordinates here and even a minus is missing here. In the fourth option a minus is missing in both the cases. So 1, 3 and 4 are wrong. Next question. Which of the following statements is true? In polymorphism we use pointer to base class to refer to all derived objects. Even when the base pointer contains the address of the derived object, it still executes the base class function. Runtime polymorphism is achieved by virtual function. In general compile time polymorphism, this will be the case. So in order to override this and make the derived class function execute, we make use of virtual functions. When we use the same function name in both the base class and the derived class, the function in the base class is declared as virtual using the keyword virtual preceding the normal declaration. So if we say there is a method like public function, the word virtual will be placed here in the base class. This determines which function to use at runtime based on the type of object pointed to by the base pointer. So here they have told even when the base pointer contains the address of the derived object, it still executes the base class function. To override this only, we are using virtual functions in runtime polymorphism by declaring the keyword virtual in front of the function declaration or the method declaration. We must access virtual functions through the use of a pointer declared as the pointer to the base class. So virtual functions do not implement polymorphism is wrong. They are a part of runtime polymorphism. Next, virtual functions do not permit calling of derived class functions using a base class pointer. Use of virtual function is to use the pointer to the base class for calling derived class function. So it will decide which function to use at runtime based on the type of object pointed to by what? By the base pointer. So this is also wrong. Virtual function is for this purpose only. They have given do not permit. So next two options we have to know about pure virtual function. A pure virtual function is a function declared in the base class that has no definition relative to the base class. So here pure virtual functions can never have a body. It means they don't have a definition. Is that so? No. Actually they have a definition but it is not related to the base class. That is the case. So this is also wrong. Now the question is which is true? So obviously option number 3 will be the right answer. What is the statement? We can never build an object from a class containing a pure virtual function. So classes containing pure virtual functions cannot be used to declare any objects of its own. This is the statement that justifies the option 3. We can never build an object means no object can be declared. Such classes are abstract base classes because you are declaring this pure virtual function in the base class. A virtual function equated to 0 is called a pure virtual function. So we can say there is no object from abstract base classes. Next question. What is the output of the following program? Inside the main function, they have initialized I is equal to 3. Then there goes a while loop. The while loop is from here to here. Then we have a print statement after the while loop. So this is the beginning of the while loop. This is the ending of the while loop. We have three statements inside the while loop. One is initializing I is equal to 10. Then we have I decrement, that is I is equal to I minus 1. Then we are printing I. So let's get into the main program. I is equal to 3. We are initializing this. And here I is equal to I minus 1, which says the value of I is 2. Inside the loop what happens is we have I is equal to 10. I minus minus will make I is equal to 9 and I am printing percentage %d. So only 9 will be printed here. In the output you will have 9 here. We will go to the while loop now. I is equal to I minus 1 will make the value of I to be 1. Again we get into I is equal to 10. Then I is equal to I minus 1 will make I is equal to 9. We are printing another 9. So along with the previous output 9, we have another 9. Again we are getting into the loop. I is equal to I minus 1 which is equal to 0. This I is equal to 10 because we are initializing it again here. This will be treated as a local variable that is bound to the while loop alone. And I is equal to I minus 1 will make it 9. Another 9 is printed. So along with the two 9s, the third 9 is also printed. Now I is equal to I minus 1, which will make the value minus 1. When the user types in a negative number inside the while loop, the condition of your while loop will not evaluate to true. It will be true when it is greater than or equal to 0. While loop will be true for values that are greater than or equal to 0. While loop will be evaluating to false when the value is less than 0. Here, once it gets to the value of minus 1, it becomes less than 0. So, here it will exit the while loop. It will not go inside the loop here. So, once it exits, you have another printf here. What does it print? The I value. What is the I value now? It is minus 1. So, 999 along with that minus 1 is printed. Inside the loop is local to the loop. Inside the condition part of while loop is global I. It is available for the whole program, but inside the loop only this I will be available. Whenever you get inside the loop, I will be initialized to 10 every time because they have given int I is equal to 10. So what is the final output you got here? 999 minus 1. Option number 3 will be the right answer. You can use any online C compiler, type the complete program and give print statements everywhere wherever you get doubts and try to understand how it executes. Next question, the hue of a color is related to. Of course, this is computer graphics question. A light source such as sun or a standard household light bulb emits all frequencies within the visible range to produce white light. When white light is incident upon an opaque object, some frequencies are reflected and some are observed. The combination of frequencies present in the reflected light determines what we perceive as the color of the object. If low frequencies are predominant in the reflected light, the object is described as red. In this case, we say that the perceived light has a dominant frequency or dominant wavelength at the red end of the spectrum. The dominant frequency, the dominant wavelength is also called the hue or simply color of the light. So in this case, the dominant frequency is called the hue. What is the dominant frequency otherwise called? It is called the dominant wavelength. So frequency, wavelength and hue all are same here. So we can mark option 4 to be the right answer. So we will also learn about the other 3 options. When we view a source of light, our eyes respond to the color, the dominant frequency and 2 other basic sensations. What are the 2 other sensations? One of these we call the brightness, which corresponds to the total light energy and can be quantified as the luminance of the light. So luminance is talking about the brightness and brightness is about the total light energy. So first is luminance and the second one is the hue and the third one is what we are going to see next. The third perceived characteristic is called the purity or saturation of the light. So purity is saturation. Purity describes how close a light appears to be to a pure spectral color such as red. So saturation is about purity. So they say one of these and they have given the third. It means luminance, then we have hue, then we have saturation. Chromaticity is used to refer collectively to the 2 properties describing color characteristics, that is purity and hue. We call them together as chromaticity. Radiation emitted by a white light source has an energy distribution that can be represented over the visible frequencies. So such kind of radiation is what we call as incandescence. Next question. What is the output of the following program? Hash include stdio.h. Then we have something called hash define. The hash define directive tells the compiler to substitute the function macro whenever it sees the function name. So what is inside the function macro? You have to multiply x with itself. So sqr of x is x into x. Now we will get inside the main program. Int a comma b is equal to 3. So b is initialized to 3. A is equal to square function. Inside we have the argument, namely b plus 2. What is the value of b? It is 3. Whatever is inside the brackets will be taken to be x. So what is the definition of square function? It is x into x. Now what is in the place of x? X is equal to b plus 2. So in the place of x into x, we will be using b plus 2 into b plus 2. Now what is the value of b? It is 3. So when I substitute b is equal to 3, this x into x will be 3 plus 2 into 3 plus 2. Now what will be the usual precedence of computation? Multiplication will take the first precedence and then addition will be taking place. So the first precedence will be given to multiplication. 2 into 3 will give you 6. And then you have to add the other two sides. 3 plus 6 is 9. 9 plus 2 is 11. So A will have the value of 11. We are printing A in the next statement and return 0 is given since we have used int main. So what is the value that will be printed? It is 11. Option number 2 will be the right answer. If you want to have good clarity of how this is working, you have to use it in an online C compiler and just try changing the values and then work it out manually in a paper, and then you will be able to understand how this precedence operation is working. So let's take two examples. The first example, let b stay as 3. A is equal to square of b plus 3. Now how this will be interpreted is x into x will be b plus 3 into b plus 3. So 3 plus 3 into 3 plus 3. So 3 into 3 is 9. So 3 plus 9 plus 3, which will give a value of 15. The second example, when you pass the value like b plus 2, now this brackets will take the highest precedence. So what will happen is, first b will be substituted by 3 and this operation will take place first. So this becomes SQR of 5. SQR of 5 will give 5 into 5 as per the function definition, which is equal to 25. This is the value that has been given in option number 1. So usually we do this mistake. Only when it is included in the bracket, you can first sum it up and then go with the function definition. But when it is used without brackets, when it is just plainly given as b plus 2, you have to go for this kind of computation. Next question. Consider the 3 points P1, P2, P3 and a viewpoint C. Choose the correct options. In 3D scene, the identification and removal of surfaces that are blocked or hidden from view is called hidden surface problem. So from this part only they have asked this question. Any hidden surface algorithm must determine which edges and surfaces are visible either from the center of projection for perspective projections or along the direction of projection for parallel projection. Center of projection is for perspective projection. Along the direction of projection is for parallel projection. So here you have a term called obscure. Obscure means not able to see properly or clearly. They are given 3 points P1, P2 and P3 and a viewpoint C. The equations of a line determined by 2 points P0 and P1 are given by x is equal to, then y is equal to and z is equal to. These are the equations of a line. So they are asking which point is actually visible and which is hidden. To know that, we have to find the equations of a line determined by 2 points. So let's do it for point C. 0, 0, minus 10 and point P1. This is 1, 2, 0. As per this equation, now we will take this to be x0, y0, z0 and this to be x1, y1 and z1. X is equal to x0, 0 plus x1 minus x0. x1 is 1 minus 0 into t. So we can say x is equal to t. Then we have y. y0 is 0 plus y1 is 2, 2 minus 0 into t. Y is equal to 2 into t. Then we have z, minus 10 plus 0 minus of minus 10 into t. This will be minus 10 plus 10t. So z is equal to minus 10 plus 10 into t. This is between C and P1. So let's take a viewpoint here as C and let's take P1 here somewhere. So this is from C point to P1 point. We have found these lines of equation. Now we will determine whether P2 is lying on this line. Either A is possible or B is possible. So they say P1 is obscuring P2. In B they are saying P2 is obscuring P1. Only one of the statement can be true. If any of the option is giving both A and B, rule it out. To tell in Tamil, ஒன்னு P1 P2 மறைக்குதுன்னு எடுத்துக்கணும், இல்ல P2 P1 மறைக்குதுன்னு எடுத்துக்கணும். ஏதாவது ஒன்னு தான் இதுல உண்மையா இருக்கணும். Either P1 is giving an obstruction to P2 or P2 is giving an obstruction to P1. So take this to be P1 and take this to be P2. So seeing from C, either this should be the case or C P2 P1. This should be the case. Both cannot happen. So this is about A and B. You have to find which is true from A and B. From this we can understand C and D are perfectly right. So these two are correct. Now let's go for point 2 to determine P2 3, 6, 20 lies on this line. Which line? From C to P1. We see x is equal to 3 here. X, y, z is given. From this we can find t. So t is equal to 3. In this equation we have found that x is equal to t. So from this coordinate using x is equal to 3 we can take t is equal to 3. X is equal to 3. Y is equal to 2 into 3 which is equal to 6. Then z is equal to minus 10 plus 10 into 3 which is equal to minus 10 plus 30 which is equal to 20. 3, 6, 20. When t is equal to 3, you get the P2 points exactly. From this we can say P2 lies on the projection line through C and P1. Projection in the sense you have to consider this in three-dimensional form. We can say C occurs when t is equal to 0. Just substitute the points. X is equal to 0, y is equal to 0 and z is equal to minus 10. We are getting the coordinates of C here. P1 occurs when t is equal to 1. So x is equal to 1, y is equal to 2 and z is equal to minus 10 plus 10 into t is 10 which will give you 0. This is exactly the coordinates of P1. And P2 occurs when t is equal to 3. So this is x is equal to 3, y is equal to 6 and z is equal to 20. Now we will leave this and get a clear image. So this is C and this is P1. This occurs at t is equal to 0. This occurs at t is equal to 1. And now when t is equal to 3, you will obviously have P2 in the projection line of C and P1. So P2 is actually available here where t is equal to 3. We determine which point is in front with respect to C. From this, comparing the t values, we can understand P1 is in front of P2 with respect to C. So I can say P1 is obscuring P2. P1 வந்து P2 மறைக்கிறதா நம்ம எடுத்துக்கலாம். So in that case, if viewed from C, P1 is obscuring P2 and so we mark A to be true which will make B to be false. So we have to choose only the correct options. In that case, we are marking option number 2 to be the right answer. Now we have to check if P3 is on this line or not. So P3 is 2, 4, 6. So from this we can check for t is equal to 2. So let's take P3 2, 4, 6. So here t is equal to 2. We have to check whether it is obscuring P1 or P3. We know C and D are true. Even then we'll check. So x is equal to t. So we have x is equal to 2. y is equal to 2 into t. 2 into 2 will give 4. So x is 2, y is 4. So far right. What is z? Z is equal to minus 10 plus 10 into t. 10 into 2 will give 20. 20 minus 10 will give 10. And z is equal to 10. So if P3 has to lie on the same projection line, it should have coordinates 2, 4, 10. But here it has 2, 4, 6, which makes it evident that P3 is not on this projection line. 2, 4, 6 can occur somewhere here, but not on this line. So it neither obscures nor is obscured by P1 and P2. P1 will not hide P3, P2 will not hide P3 at the same time. P3 will not hide P2 and P3 will not hide P1. P1 P2 P3 மறைக்காது, P3 P1 P2 மறைக்காது. P3 does not obscure P1. If viewed from C, it is true because it is not lying on the projection line. P2 does not obscure P3. It is also not going to disturb P3. So this is also true. So we are just trying to find how C and D are true. Next question. Which statements are correct? So we have a set of statements on constructors. Constructor is invoked at the time of object creation. Whenever the object is created, constructors are invoked automatically. It is perfectly true. A is correct, so we can exclude 3 because it does not have A. If you have a class named A, inside the class definition you will have a method called A that is with the same class name and you will have a definition inside. So whenever you create an object for A, if I say A, then it will automatically invoke this particular method. In fact, other methods are usually called using their name, but constructors you need not call them. Next statement is about return type. Constructor cannot have a return type, not even a void return type. So constructors do not have return types, not even void, and therefore they cannot return values. It is true. In this case, 4 is also ruled out. Next they are saying constructors are not inherited by subclasses. Subclass means derived classes. But the constructor of the superclass, the base class, can be invoked from the subclass. There is a base class and we have derived 1 and derived 2 class. The constructors are not inherited here. But the constructor of the base class can be invoked from the subclass. It means inside the subclass or inside the derived class, I can invoke the base class constructor. So constructors cannot be inherited. It is right. Though a derived class can call the base class constructor is what this statement said. So C is also right. So if I mark A, B, C as true, obviously we know D is false. And option 1 is also ruled out. Option number 2, A, B and C will be the right answer. But what is false with D? A constructor cannot be virtual because at the time when the constructor is invoked, the virtual table would not be available in the memory. This is the reason behind why it cannot be declared as virtual. Cannot be declared as virtual will be the right statement. Can be declared is the wrong one here. Next question, match list 1 with list 2. If you have gone through the previous year question papers so far, you could at least map 2 or 3 algorithms here. So whenever we say Bressenum, it always ends up with Bressenum's line algorithm. So Bressenum's line drawing algorithm will be like this. So we will plot points little by little and then draw a line through the points. So A is mapping to 2. Except the first one, everything is having 2. Then we have Cohen-Sutherland's algorithm. Cohen-Sutherland line clipping algorithm. So B is mapping to 3. A2, B3. Again we have 2 options. Let's rule out 4. Next one is Sutherland-Hodgman algorithm. Question in the previous year question paper was, which polygons are clipped using Sutherland-Hodgman algorithm? Whether it's convex or concave they have asked. So C is mapping to 4. C4, and so option 2 is also ruled out. Option number 3 will be the right answer. So it is polygon clipping here. And then the final one, Z buffer. This is a hidden surface removal algorithm, and D will be mapping to 1. A commonly used image space approach for detecting visible surfaces is the depth buffer method. This approach is also frequently referred as the Z buffer method because object depth is usually measured along the Z axis of a viewing system. Since the depth is represented by Z axis, we call this as depth buffer method or Z buffer method. So can you see the view plane and 3 points? Now we'll just use another question's explanation here. Consider this to be C, this to be P1, this to be P2, and this to be P3. Just before 2 or 3 questions we saw about obscuring images. This is the actual case. So I am trying to map that question's explanation with this diagram since it will be easy for you to map it. Next question, consider the following code segment. They have initialized an array. Whenever we have array values and we have a pointer here, if I say pointer is equal to ARR, the array, which indirectly means it is array of 0. And now the values of the array are 0, 1, 2, 3, 4. And this is the index position. These are the values. The pointer is given ARR plus 2, which means the pointer is here. Arrange the following printf statements in the increasing order of their output. The value of I is initialized to 1. What is PTR of 1 here? Since the pointer is here, this will be taken as the 0th index. When I say it is PTR of 1, it means it is referring to this position. This is PTR of 1. So I have the value 3 here. Next one is I plus 1. I plus 1 means it is PTR of 2. So this is PTR of 2. This is the general case I have told when it is ARR. But here it is ARR plus 2. So for the pointer, this is the base index. This is the 0th index. Next we have minus I. Minus I means just minus 1. So from 0, I have to move to minus 1. This is minus 1 and I have the value 1 here. Next is minus I plus 1. That is minus 1 plus 1, which is equal to 0. What is PTR of 0? It is 2. Usually when they point a pointer to an array, it refers to the base index 0. But here they have initialized the pointer to array index plus 2. It means array of 2 is assigned to pointer of 0. Array of 3 is initialized to pointer of the next element 1. Array of 4 is referred by pointer of 2. What is before 0? So it is pointer of minus 1, which means it is referring to array of 1. What is an array of 1? It is 1. What is an array of 2? It is 2. What is an array of 3? It is 3. What is an array of 4? It is 4. So what is the order? It is minus 1, 0, 1 and 2. Which gives minus 1 here? C gives minus 1 here. So C comes first. Then which gives 0? D gives 0 index. So D comes next. Then we have 1. A gives 1. So A comes next. I plus 1 gives 2. And so B comes next. They have used only these 4 elements. They have not used this element. The first element is not used. So C, D, A, B. Option number 2 will be the right answer. If you still have doubt, please use online C compiler and print all the statements. Next question. Given below are 2 statements. The friend function and the member functions of a friend class directly access the private and protected data. The next statement, the friend function can access the private data through the member functions of the base class. A friend class can access private and protected members of other classes in which it is declared as a friend. It says that statement 1 is true. In C++, friendship is not inherited. That means if a base class has a friend function, then the function doesn't become a friend of the derived class. In principle, a publicly derived class inherits access to every member of a base class except its constructors and destructor, its assignment operator members, its friends, its private members. It means a publicly derived class can inherit every member of a base class, and these are the four exceptions. Derived class will not inherit all those things. The friend function can access the private data through the member function of the base class is true. Derived classes alone they have mentioned here, they have not mentioned about the base class. So if I declare something in the base class, I can obviously access the private data. Usually friend function and friend class member functions can access private data, which means if I have a friend function in the base class, I can access the private data. These statements are with respect to derived class. This particular friend concept is not inherited. That's what they have given. Friendship is not inherited. The explanation is for derived class, but the statement is about the base class. From this we can conclude option 1. Both statement 1 and statement 2 are correct as the right answer. With this we are completing unit 3 questions.